This video is part of the Finance Fundamentals TVM crash course. Stay tuned until the end for more details on where to find other videos in the series, as well as information on how to get a copy of the documentation and access to the question bank that support my YouTube series. Just by way of setting up the context for the crash course, it is arranged into three main areas. Section A on core skills in TVM, Section B covering a selection of common timelines in the equity and fixed income markets, with Section C being a wrap-up dealing with various other matters. This video is numbered B1, which means that it is the first and also the simplest timeline that you will encounter in TVM. To an extent, I assume that you have already developed the basic skill set covered in Part A, although I will explain one or two of those issues again here. This TVM scenario is identified on the basis that it has no intermediate cash flows. Typical examples of instruments with this cash flow pattern are a zero coupon bond or a non-dividend paying share with a terminal value. All that happens on the timeline for such instruments are a value or price today, labeled PV at T0, and a value or price at the end of the timeline, labeled FV at point N, which is also called the maturity date or terminal valuation date. These two values are separated by a number of periods shown as numbered notches on the timeline. Quite often, but definitely not always, these notches will mark the number of years. But the periods that you count on your timeline must match the periodicity of the compound rate that applies in the situation. Although I discuss periodicity issues in detail elsewhere in this crash course, I note briefly here that if the discount rate is compounded monthly, then you have 12 periods or notches on the timeline for every year. If the rate is compounded quarterly, then you will have 4 notches per year, and so on. It is only when the discount rate happens to be compounded annually that you have the luxury of switching off and simplistically marking your timeline on a year count basis. One quick side note about periodicity. It is my long experience teaching finance that students focus too intensely on the timing of cash flows when they make their periodicity decision. This is not the way to do it. Periodicity is a function of the compounding rate, not the cash flow frequency, even though there might sometimes be situations where the dates are the same. The cash flow pattern in this video is a classic example of where the compounding and cash flow dates are different. There are 0 cash flows between the start and end of the timeline, but there are still plenty of compounding notches. Next, let's take a look at the two different ways in which you can calculate the various unknowns for a timeline such as this. You could use the 5 key TVM inputs of your financial calculator to solve for present value, future value, or rate of return, but I don't recommend that at all. Use the equations instead. In fact, I go so far as to say that you should memorize those equations and practice recalling them, because they are just so pervasive in finance and really useful. Even if they look a little bit daunting at first, I can practically guarantee that they will become old friends. It is perhaps only when solving for n, the number of periods, that you might want to turn to the 5 key functions. But even there, you need to be aware that your calculator may return an unreliable approximation, and only the equation is guaranteed to return the exact answer you're looking for. Finally, a couple of short examples. Here, you are asked to calculate the market value of a zero coupon bond with a face value of 100,000 Rand. The bond matures 4 years from today, and its market yield is 8.2% stated annual compounded semi-annually. The rate supplied for this bond is compounded semi-annually, which means, of course, twice per year, so the timeline must be marked up in 6-month periods. Therefore, there are 8 periods between T0 and maturity date, not 4 years. The market value today is PV, the unknown. The face value is 100,000 Rand, which is the amount receivable by the bond investor at maturity. So this is also the future value at T8. The discount rate of 8.2% must be divided by 2 to get the correct rate per 6-month period, which is 4.1%. Then we use the equation as the preferred method to calculate market value, which is PV equals FV divided by 1 plus R to the exponent of n, which equals 100,000 divided by 1.041 to the 8, which equals 72,509 Rand. In the last example for this video, we turn attention to the equity market. Here we consider a fairly plausible situation in which a share is not expected to pay any dividends in the near term. After 3 years have passed, the analyst forecasts a terminal value of 375 Rand for the share. Where does that value come from? Well, the calculation might be done using a method such as applying a justifiable price-earnings multiplier to a 3-statement model forecast of year 3 or year 4 earnings, but those are topics for another video. Back to this example, we are asked to calculate a value for the share today given a required rate of return on equity of 12.2%. The first thing to note regarding periodicity is that when we are talking about equity returns and valuations, we tend not to be too specific about periodicity. In fact, it's very common that you may see a rate of return on equity without any guidance on the compounding frequency, or in fact even that the rate itself is annual. This is because equity returns are almost always assumed to have a periodicity of 1. So if you are given no information other than a percentage rate for an equity return, you are absolutely entitled to assume that it is an annual rate compounded annually. Therefore, turning to the timeline, we understand that this is the simplest case where the notches are the same as years. So today's value for the share is its terminal value of 375 Rand divided by 1 plus 0.122 raised to an exponent of 3, which equals 265 Rand and 49 cents.